Let's learn a little bit about ions. Okay, an ion, first of all, let's just throw the definition up here. You should be copying this in your notes. An ion is an atom with a positive or negative charge. Okay. Now, technically, an atom can have neutral charge, but then it's not called an ion. An ion is when it's either positive or negative. Okay. We'll talk about how that happens in a moment, but mostly what we're writing down in these notes is vocabulary. Okay. Positive ions they have a special name. Okay, those are called cations. And this is how I remember that. How do I remember cations from anions? Because cations are positive. It's like a cat, right? And you can probably guess from that meme that anions, that's the name of a negative ion. Oops. I'm writing the wrong one. Anions. So cations and anions, okay? We are in the bonding unit. So you might have guessed already before I start digging too deeply into this that ions form during ionic bonding. That's why it's called ionic bonding, right? If you remember, ionic bonds form when something donates electrons to another atom. And when that happens, that's what causes that charge. When one atom donates, it's going to get a charge. And when another atom accepts, it's going to get a charge. So now both of those atoms are anions. Cations and anions come in pairs, right? The positive and the negative go together. What we learned in our last video, in our recent review, was that another quick fact here. Metals donate. And the reason for that was that metals, like sodium, has 1 valence electron, right? Magnesium has 2. Metals typically only have a couple of valence electrons, right? All they have to do is get rid of 1 or 2 of those valence electrons, and then that satisfies the octet rule for them. They have a full outside shell. So metals donate, which means metals are the cations. This can be helpful to remember. Okay, when you're looking at a periodic table and you're looking at the left side, the metals, those are all the cations, and on the other side is the nonmetals. Nonmetals have lots of valence electrons, like fluorine has 7, for example, only needs 1 more. Nonmetals accept, right? A metal will donate to a nonmetal. So nonmetals are anions. Okay, so half the periodic table is the cations, half the periodic table is the anions. Now, what you might not get is that metals donate, right? They're losing electrons. Why are metals positive, right? Cations are positive. Why do you get a positive charge if you lose an electron? Well, let's take a look at an example. Sodium, right? 11 electrons total. Okay, 11 protons in the nucleus total. Sodium donates 1 electron. Let's say it donates to chlorine to make table salt, right? Donates 1 electron. Now it only has 10 electrons and 11 protons. Well, protons are positive and electrons are negative. 10 negatives plus 11 positives is a 1 plus charge. Okay, and that's the simple answer, right? When you donate an electron, you're giving up negative charge. The chlorine that takes the negative charge, it's taking negativity, right? So it's going to get a negative charge and become an anion. Okay. What you're going to see on worksheets and tests is stuff like this. I'm going to just give you an element, right? Magnesium. It has 2 valence electrons, and you need to recognize it only has 2 electrons. It's going to donate both of those 2. So I'm going to ask you, right, what's going to happen? What's the new charge going to be? And then ions have their own symbols and names. And we're going to work those out. So magnesium only has 2 valence electrons. It's a metal. It's going to donate 2. The charge, 2 plus. Symbol, teaching you something new here. You put a superscript with the charge up there, Mg 2 plus. Okay. The name, pretty simple. It's still magnesium, but you add the word ion afterward, magnesium ion. Why don't you try one with sodium here? It's basically the same thing that I just did with magnesium. Go ahead and pause your video and see if you can fill out these columns on your own for sodium. Okay, you've paused your video. You've tried this on your own. Otherwise, you're short-circuiting your learning if you didn't actually try it. Pause the video, try it for real. Here's what's going to happen. Sodium's a metal. It only has 1 valence. It's going to donate 1. Charge is 1 plus. Symbol, many of you probably wrote Na plus 1. Maybe you wrote Na 1 plus. The real answer is just Na plus. If it's a 1, you don't need to write the 1. And this is sodium ion. Now let's take a look at one of the nonmetals. Let's look at fluorine. Fluorine has 7. It needs 1 more. If you take a negative charge, that's 1 minus charge, and then we're going to write F minus. Okay. Now the naming for anions is a little bit different. You got to change the ending. Okay, right here. Instead of fluorine, it changes to fluoride. Fluoride is what's in your toothpaste, right? Fluoride is fluorine that has gained an electron. I want you to try another one yourself. Let's do oxygen. And I'll give you a clue. Oxygen has 6 valence electrons. And remember the octet rule, it's trying to get to 8. Go ahead and pause the video now and try this. Okay, you've paused and you've given it a shot. Oxygen needs 2 more. It's a nonmetal. It's going to take 2 more to get to 8. That's going to give it a 2 negative charge. So the symbol will be O2 negative. And the name, if you said oxygenide, I forgive you. It's actually oxide. And then I'm just going to write in red, anions have "ide" for the name ending. You're going to get an assignment with more practice on this, but this is the basics to get you started. And then just to sum all this up, this is only for ionic bonding. Okay? All of this is for donating and accepting. That's it. None of this has anything to do with covalent bonding. With sharing, you don't change the name endings, okay, necessarily. So remember that this is all for ionic, and don't get the 2 sets of rules mixed up. Good job.